Hi, hello, and a very warm welcome to all of you. My name is Hoogestraat. I'm a geophysics master student at Kiel University, Germany. And even though you can't see me right now, I would like to tell you a little bit about detecting very slow ground motion from radar satellite data over Schleswig, Holstein and Hamburg. To begin with, let's have a closer look at the geological setting. The region we are talking about is a part of the North German basin, the southern part of the Paleozoic Permian section sea. Today, this area is covered by hundreds or even thousands of meters of sediments, of which the uppermost layers were squeezed and superimposed by glacial deposits during the last ice ages. In this region, ground motion is a phenomenon that happens on a scale of only a few millimeters a year. Nonetheless, and as you already can see here, there's quite a lot of high-quality data on ground motion available, covering a period of time spanning from 1992 until now, gathered by ESA satellites EIS-1, 2 and Sentinel-1 respectively, processed to PS time series by the German Aerospace Center DLR. But there are still some critical facts to consider when dealing with this data in terms of very slow ground motion. Firstly, for this region, old ARS data falls into three parts. This results in often only weakly stationary data. We take care of this by recalculating those displacement rates where the variance to the left side of the gap significantly differs from that to the right side. This careful operation results in a better signal-to-noise ratio. The second and even bigger problem is the fact that A, data from different tracks or satellites shows different characteristics, and that B, very slow ground motion lies outside the confidence intervals of deformation rates you get for PS-INSAR time series. Our solution is not to examine absolute movements, but to evaluate movements in relation to the distribution of deformation rates in the region they belong to. In other words, we don't look for a reference point. We accept the distribution's mean value as a zero mark inherent to the data. This does not alter the data at all, but for us it was some kind of a game changer. Coloring displacement rates around sigma classes allows to clearly identify widespread movements as well as smaller structures. This here now is again Hamburg, where you find bluish inner city now, the harbour area characterized by subsidence in red, and a big red dot in the southeast, the former gas caverns of Wright Brook. Furthermore, we are able to clearly identify the Elbe marshlands as a vast region of accelerated subsidence along the Elbe River. Driven by dewatering, ongoing settlement and compaction processes and anthropogenic impact, these marshlands subsidize with rates from 2 up to 15 millimeters a year. An example of a smaller structure we found is a line of strong subsidence along the edges of Lübeck's Old Town. This line almost perfectly traces a region of anthropogenic filth over peat. And you perhaps want to take notice of the fact that even though there's still a shift between ERS values and Sentinel data, both distributions nearly show the same shape. This is a phenomenon we often experience, and it helps us to compare data from different sources. A relatively new technique we are working on is the use of anthropogenic installations for calibration purposes. Our best bet at the moment are transmission towers on areas with strong hydrological influences. These towers are founded deeply to get rid of near-surface processes. For a first test case, we used transmission towers along the Elbe River to calibrate displacement rates over one of Brunsbüttel's industrial areas. What was surprising for us is that there are areas sinking faster than the rest around, and in this case especially those around the former nuclear plant of Brunsbüttel. To conclude, PS-INSAR satellite displacement rates can be used to detect and measure even very slow ground motion processes. To do so, scales in terms of classes of standard deviations should be used. Where appropriate, anthropogenic installations are useful to calibrate displacement rates. Thank you very much for your attention, and if there's something left, please don't hesitate to get in contact.